Hello again everybody. We do have a little bit of a warm-up for today's lesson, so just have a look at the two post-it notes, have a little try at those. When you're ready, here are the answers. I hope you can see that we've got a right angle here, and we know that a right angle, the total number of degrees in a right angle is 90 degrees, so those two angles are going to add up to 90 degrees, and I hope you can see that that makes this value of x, this angle in here, 60 degrees. So x would be 60 degrees. In the second one, we haven't done this kind of thing since year 7. Now I've got two parallel lines here, so I better mark them as parallel. And what we learnt in year 7 was that alternate angles are equal, and then we have to remember which ones the alternate angles are. The angle that's alternate to this one here is this angle here. Now you could get out a protractor, a ruler, and measure that all up, but that's something that hopefully you can see that those two angles would be the same size. And when we did that in year 7, you might remember that they were called Z angles. Sometimes we call those ones Z angles because if I look at that bit in there, I can see a Z. So keep in mind those two things for our lesson today. All right, I've called this lesson Planes and Boats, but more traditionally it would be called Angles of Elevation and Depression. So that's what we're going to look at today. I should tidy that up a little bit. So that's an A for angles and elevation and depression. All right, but I'm going to talk about planes and boats because that's much more fun. What I've got here is a very bad drawing, so I apologise, but this is a person, they're lying on their tummy with their binoculars looking out over the cliff. Now what they can see is they can see a plane up in the sky and they can see a boat down in the water. Now I'm going to give you some information about what that person somehow knows, and we're going to calculate some things from there. So we're going to just label this is our horizontal line of sight. So this is the person, if they look straight out that way, that's a horizontal. So that's going to help us to make some right angled triangles. Now what this person happens to know, let's just look at the plane first of all. They happen to know that the distance out to the plane is 100 metres. And they happen to know that from that point out there straight up to the plane, the distance is 80 metres. So this is not very realistic because, well, how would that person know that? But just stay with me. Okay, what we're really interested in finding is the angle up to the plane. And I'm going to call that alpha today. Remember, we use our Greek letters for our angles. So we're going to find that angle first. Now this is not new. We've done this before when we're finding angles, missing angles in a triangle. We've got our right angle triangle here now. And the first thing we do when we find a missing angle is to label the sides we've got. So for this triangle here, I've got an adjacent and I've got an opposite. So using my SOHCAHTOA, O and A, a tan. So this is a tan question. Now not all our angle of elevation depression questions will be tan. Sometimes they'll be sine, sometimes they'll be cos. But this one's a tan question. So if we were to solve our plane question here to find that angle, we would say that tan of alpha is equal to the opposite, which is 80, over 100, which is our adjacent. We put into our calculators that alpha equals tan to the minus 180 over 100. And just answering to the nearest degrees, you can pause and do that one yourself. You will end up with alpha equals 39 degrees. So we've just found that this angle in here is 39 degrees. And in fact, what we've found is the angle of elevation. The person looking out that way has to lift their gaze 39 degrees or elevate their gaze 39 degrees to be able to see the plane. So this angle in here is the angle of elevation. Great, we found the angle of elevation. Now I'm going to tell you some information that this person knows about the boat. They know that they're on a cliff which is 45 metres high. Now I've just realised that my scale is terrible here. I've said that this is 80 metres and now I'm saying this that looks a lot longer is 45 metres. So I apologise for that, but it's not going to make any difference to our answer. What this person also knows is that this ship here, or it's just a sailing boat, is 120 metres out from the base of the cliff. So we've got another right-angled triangle here that we can create. And what we're going to find is this, we're going to have, say this person's their line of sight, we're going to find, now I'm going to call this angle beta, and we're going to find this angle in this triangle. So again, this is not difficult because we've practiced this in our last exercise, finding a missing angle in a triangle. So we're going to call this side here the adjacent. You might like to pause and finish this off yourself. This side here is the opposite. So again, O and A, this is another tan question. So this time we're dealing with the boat. And we know that tan of beta this time is equal to the opposite, which is 120, over the adjacent, which is 45. So beta will be equal to tan to the minus 1 of 120 over 45. And on your calculator, pause if you like, I've ended up with an angle of 69 degrees to the nearest degree, so I'm just rounding off. So I've found that this angle in here is 69 degrees. Now this is where you have to be really, really careful. We have not just found the angle of depression. We found this angle in here. But that's not how far down this person had to look. This person had to look down, whatever that angle in there is, to see the boat. They didn't look down 69 degrees. 69 degrees is in here. So this angle here, well, we can find that because we said in our warm-up that if you've got a 90-degree angle and you know that this is 69, this angle in here must be 90 minus 69. So this is 21 degrees. So in fact, the angle of depression from the line of sight down to the boat is 21 degrees. So this here is our angle of depression. But I think you'll agree it was easier to find that angle there first and then work out what the angle of depression is. Now, two more things. One, just notice that the angle of depression here, 21 degrees, is the same as this angle here, 21 degrees. Now, you can be convinced of that two ways. One is because these are alternate angles. There's our Z. Now it's a bit backwards this time, that's okay. Z angles can take a couple of forms. There's our Z, so this is 21 and that's 21. Or you could have said this is a triangle. Triangles have an angle sum of 180 degrees. So this is 90, this is 69, this has to be 21. But the main thing to know is that this is our angle of elevation, the person looking up, and this here is our angle of depression, looking down. So the last thing I want us to do, because that's got a little bit condensed with stuff, a little bit hairy, is I've just drawn my picture again over here, and all I'm going to put into it this time, that's meant to be a horizontal line. You should use a ruler. That angle in there is our angle of elevation, and this angle, I'm going to do it in a different colour. I'm going to do it in blue. It's this angle in here, which is our angle of depression. Now in my next video I'm going to work through some examples of these questions because they're usually worded questions, which makes them a bit harder, and getting the hang of elevation and depression can be a bit tricky. So in the next video I'll do some of the exercises, some of the questions that might be out of your textbook or might be out of a different textbook. So I'll see you soon. Bye.